we are going to go backwards with our ellipses today. So today we are going to be given information about the graph, and we're going to have to write what the equation is in standard form. No, we graphed 3 problems in there too.
Oh, we did it for.
You did the graph, right. Okay, so here's a reminder what our ellipse looks like. Okay, we have a center, we have major vertices, minor vertices. Okay, I labeled these as the major and minor axes because you could be given information about that. How long is the major axis? 2A. How long is the minor axis?
2B.
2B. And we know that our foci are C away from the center. Okay? And here's just an ellipse of a planet orbiting the sun, a sun. Okay? Planets orbit in elliptical patterns, so this is why it is applicable. Alright? Anybody in astronomy?
I'm
No.
in physics.
Okay. Astronomy, have you talked about orbits of planets?
Yeah.
You talk about their shape?
Yeah.
Now, do some of them change, or are they constant?
Yep.
They change a little bit, but they're still in elliptical pattern. Okay, you should find that out. Right.
It changes rapidly. Like every 10 years, it changes from being a wide ellipse to a horizontal ellipse.
Okay, very cool. All right, so example number 1. We have 4 of them today. Find the standard form of the ellipse where the vertices are at plus or minus 6, 0, and the foci are at plus or minus 2, 0. Okay? Now, if it just says vertices, you're going to assume that those are the major vertices. Okay? Our book, if you notice when you checked your work, it only labeled the major vertices. The minor vertices is just something I kind of added to make sure you have the correct shape. So when it says vertices, assume that they are major. Alright? So, just like we did with parabolas, we need to draw a rough picture. Okay? It doesn't have to be perfect, it just needs to give us an idea of what is going on. So, we have 6, 0, and negative 6, 0. From this alone, we know that our ellipse is horizontal or vertical? Horizontal. When they give us the vertices, they mean major vertices. So since they're horizontally apart, we're horizontal. Alright? Now we know a couple other things. What else can we take out from this? Okay, before we get to the foci, just with what I've drawn. The center should be exactly in between, right? So the center is 0, 0, and A is what? 6. Okay. Now I'm going to plot my vertices, and vertices I mean foci, sorry. There are my foci, and what does that give us? C is 2. Alright, so let's go ahead and just write our general form for our standard equation. Alright, since it's horizontal, we're going to have x minus h squared over a squared plus y minus k squared over b squared equals 1. So what do we need? Okay, so we have H and K. We have A.
We need B.
We don't have B. But we have A and C, and we know that C squared equals A squared minus B squared. So we have 4 equals 36 minus B squared. And we really don't care what B is, we really just want B squared, right?
You add the b squared over and subtract 4.
Well, because if I subtract this, it's negative B squared equals negative 32. So both turn to positive. So what we have, X minus H squared, X squared, A squared is?
36. Wait, it doesn't matter what B squared is because
Yeah, we have B squared.
only B is.
Well, all it's asking me is the standard form of the equation.
Oh, so it doesn't have to necessarily graph.
So it doesn't ask to graph it. We're just using the graph to help us. We don't actually need to complete the graph. Okay? Plus y minus k squared over b squared is 32 equals what? A squared. Yeah. Okay? So we need H, K, A, and B in order to complete our standard form. However, if we know a combination, if we know 2 out of the 3 A, B, C, all right, we can get all 3 to complete our standard form. Any questions? Okay, now I want the standard form of the ellipse. If we have foci at 0, 0, and 4, 0, and the major axis has a length of 6. Go ahead and write down what you need to. Okay. So we have foci at 0, 0, and 4, 0. Right away, what kind of ellipse do we have? Horizontal, because we know that our foci lie along the major axis. So really quickly, I'm just going to remind ourselves of the standard form that we need to complete. Okay, so first of all, from this picture, we know that horizontal. The center is at 2, 0. What else do we know from just this? C is what? Okay, our major axis has length of 8. Okay, the major axis has length 2A, so A is? Okay. All right. Find me, what do we need? B. Find me B. Squared. Really, you can just keep it as B squared because that's what we need for our formula.
12.
B squared is 12. So our standard form, x minus h squared. X minus 2 squared over, what is a squared? Very good. Plus y minus k squared over b squared, which is 12, equals 1.
Minus the n.
Couple more. Stay with me here. Now we have an ellipse with a center of 3, 2, a equals 3c, and they give us our foci.
Oh, if it gives us a foci, then we can find
Okay, now, where's our center?
3, 2.
Okay, so center is 3, 2. We're going to need that, right? A equals 3c. We can come back to that later. Our foci are at 1, 2, and 5, 2. So what kind of... We have a horizontal ellipse.
We'll get through that.
I would, to help you. Okay? So I'm just going to go ahead and write down our standard form that we're going to need to fill out. All right, so C is 2, which means A is 6. Okay, so really we need A squared, so let's write that A squared is 36. C squared is 4, so what's B squared? This one looks familiar, kind of, doesn't it? So we have x minus 1 squared over a squared. Y minus k is, what's h?
3.
H is 3. Y is 2. Over 32. One more. This time we have vertices and eccentricity. Now, C is now 1, A is not 2. 3/6 could make 1/2.
Oh, how disappointing.
Disappointing. Let's use our vertices first. 0, 8, and 0, -8. What kind of an ellipse do we have? So we have x minus 8 squared over b squared, thank you, plus y minus k squared over a squared equals 1. We can get some different pieces of information from this. What are those pieces of information? Center is at 0, 0.
A is 8.
Which makes A 8 away. Hold on. 8 away. A squared is 64. Now, we know that the eccentricity is 1/2, and eccentricity equals what? C over A. So we know that 1/2 equals C over 8. C is 4. So C squared equals A squared minus B squared. What's B squared?
48.
So,
That's about 7.
x minus 0 squared over the smaller number b squared plus y minus 0 squared over the bigger number a squared equals 1. Yes. Always. Yes. The bigger number goes with the variable that's associated with the stretched out part. Okay? And you're getting a lot of time for your homework. What if you can get it finished before you leave?
Let's get it going.